Hello everyone, myself Rajat Gupta from Department of Physics, University of Jammu, India. Here I am presenting my research results which is on the topic microscopic study of band structure of odd proton 161 Re isotope. In this piece of research, I have done an extensive study to bring out some of the most underlying important nuclear structure properties like the backbending in the moment of inertia, the Yara spectra and the band diagram plot using projected shell model approach, and I have compared the results with the experimental data to test the accuracy of the model used. Various theoretical and experimental results have suggested that the nuclei with Z greater than 64 lying in the transition range reveals a large variation in the nuclear structure properties as we go to the higher angular momentum states, which is due to the alignment of the protons and the neutrons resulting in the variation and the change in the nuclear shape. In the present study, I have used projected shell model, which can be studied in detail from reference number 5. This model uses a deformed basis and consists of an Hamiltonian, which consists of 3 to 4 parts. The first part of the Hamiltonian is the unperturbed state, representing spherical single particle Hamiltonian. Second is quadruple interaction term. Third is monopole interaction term, and fourth is quadruple pairing interaction term. For the present set of PSM calculation, the shell model space is truncated using deformation parameters. Epsilon 2 is equals to 0.107 and epsilon 4, which is hexadecoupled deformation parameter, to be 0.027 precisely. And we're talking about the results now. The first graph is the Yara spectra, which is basically the energy is plotted along the vertical axis and the spin along the horizontal axis. And the red dots are the experimental ones and the black dots are the theoretical ones. We can see an excellent agreement is achieved between the theoretical and the experimental results. However, the experimental results are scarce. They are present up to 18 spin only, but we have predicted the results to 22 spin only. Second plot is band diagram plot, where we have plotted only low-lying bands for the sake of clarity and to extract the important underlying physics. Third plot is backbending in moment of inertia plot, and wherever there is a band crossing, there there is a backbend which appears in the moment of inertia plot, which is a S-shaped curve, which has been well reflected both theoretically as well as experimentally. And overall, the results show a considerable agreement with experimental data, which is very good. Thank you, everyone.